Hello everyone, I am Professor Sagar Pokarkar from ENTC Department of AISSMS Institute of Information Technology Pune. So today I will give the introduction about the signal flow graph. In previous lecture we see the block diagram. Now here we see the different techniques to obtain the transfer function of the system by using the signal flow graph. So this is the outline. So we see the definitions, then terminologies, and we see one example. So the alternative method to block diagram representation developed by Samuel Jefferson Manson. So the advantage is that the availability of the flow graph gain formula, also called Mason's gain formula. A signal flow graph consists of a network in which the nodes are connected by directed branches. It depicts the flow of signal from one point of the system to another and gives the relationships among the signals. So we see the fundamentals of a signal flow graph. Consider a simple equation below and draw its signal flow graph. So let us we take y equal to ax, where y is the output, x is the input, and a is the gain. So here the pictorial representation of that, x is the node and y is the output node, and which is connected by a arrow which is having gain a. So every variable in a signal flow graph is designed by a node. Every transmission function in a signal flow graph is designed by a branch. The branches are always unidirectional. The arrow in a branch denotes the direction of the signal flow. Now next is the terminologies used in a signal flow graph. So let us we take an example which is shown below the PPT, having the node x1, x2, x3 and x4, and a21, a32, a33, a43, a23 and a42 are the gain carried by that branches. Now an input node or source node contain only outgoing branch. So the input node is nothing but only the outgoing branch. So x1 is the input node and the output node or a sink contains only the incoming branches. So here x4 is the output node. Now a path is a continuous or a unidirectional succession of the branches along which no node is passed more than one. So here x1, x2, x3 and x4 is the path, then x1, then x2 and then x4 is another path, then x2, x3 and x4 is another path. Now forward path. Now this is very important. The forward path is a path from input node to the output node, and again no node should be more than one. So here for this particular figure, x1 to x2 to x3 to x4, this is first forward path, then x1 to x2 and then x4, this is another forward path. So there are two forward paths. Then feedback path or feedback loop is a path which originates and terminates at the same node. So here x2 to x3, that means x2 and then again x3 and again going to the x2. This is first feedback path. Then self loop. Self loop is a feedback loop consisting of the single branch. So here A33 contains the self loop. Then gain of a branch is the transmission function of that branch. So the path gain is a product of branch gains encountered in traversing a path. So the gain of forward path, if we take an example x1 to x2 to x3 to x4, then gain associated with this is a21 into a32 into a43. So this is the gain. Then loop gain is the product of branch gain of the loop. So the loop gain of feedback loop x2 to x3, if we trace, then its loop gain is a32 into a23. So this is the loop gain. The two loops paths or loop or a path are said to be non-touching if they have no common nodes. This is also an important point to be noted here, that is non-touching loops. Now whatever we see, now let us we take another example and we identify with the help of this example whatever we learn. Now this is the example, R of S is the input node and C of S is the output node, and these are the gain. So for this particular example, we calculate the input node, output node, then forward path and its gain, then feedback path or loop and its gain, and non-touching loop and its gain. Now why it is important? Because while using the Mason's gain formula, we require this thing. Now let us we calculate the things. Input node is R of S, output node is C of S. Now total number of forward path is G1 to G2 to G3, G4 and then G5. So this is first forward path. Second forward path, which is shown by a dark line if you observe. Second forward path is F2 we say, which is from R of S to G6 and then G5. So G6, G5 is a second forward path and its gain is G6 into G5. Then we see the loops. So first loop is L1, you give the name, having gain is minus G2 into H1. Then loop L2 is G3 into minus 1, that is minus G3. Then loop L3, the gain is minus G4 into H2. And loop L4, which is G3 into G4 into G5 and into minus H3. So this is the gain. So there are 4 loops and we calculate their gain also. Now the last point is non-touching loop. So if you look at the figure carefully, the loop L1 and L3 are non-touching. Non-touching means what? There should not be any common node. If you let us say the example L1 and L2, G3 is or X3 is the common node. When we see L2 and L3, X4 is a common node. When we see L1 with L4, X3 is common node. For L2 and L4, X3 is common node, X4 is common node. So here the two non-touching loops are only L1 and L3. Similarly, we can calculate the 3 non-touching loop also, but there is no possibility that 3 loops which are non-touching. So here only the possibility is 2 non-touching and that are L1 and L3. So the gain of L1 and L3, we know L1 and L2 and L3. So L1 into L3 is G2H1 into G4H2. So there is no 3 non-touching loops. So these are the terminologies used in the signal flow graph. So I hope you understand which are the main terminologies. I repeat again. The first is forward path and its gain. Then the loop, its gain. then non-touching loops. So there may be two non-touching loop, there may be three non-touching. So thank you.